Yes, good evening. This is BBAK Technologies. Today we are talking about Sparrow Search Algorithm. This is based on studying how the sparrow, group of sparrows will search for the food. Based on that, in a given solution space, how do you find the best solution? Means sparrows are searching for the best food. Similarly, we are searching the best solution in ocean of solutions. We are going to choose the best solution. So now I'm going to explain the algorithm how that works in simple manner. So I will consider 10 sparrows at this moment. So there is sparrow 1. There is sparrow 2. I am ordering all sparrows in 1, 2 like that. Sparrow 2, sparrow 3, sparrow 4, 4, sparrow 5, 5, sparrow 6 in and descending order means best. The sparrow that is at the best solution means best food will be listed at the top, because they started each a group of sparrow in its search. All sparrows search at rush from the random position. So now they are at the position. I ordered them in 1 2 3 because S1 is at the best position compared to the S5 or S6 or S7. So I am taking as an example, I am taking 10 sparrows, 10 sparrows for explanation purpose. So there are 10 sparrows as marked in on the screen. So you can see. So out of these 10 sparrows, S1 is I listed at top because S1 is at the position where the best food is available. Means best solution is there. Our objective is to search for the best solution for the given problem. So there are thousands of solutions available. Out of that, we want to find one best solution. So S1 is at the one best solution. Maybe right now we know only, see, each sparrow had one particular location. Means each location stands for one solution. So we know 10 solution at this moment. Out of 10 solution, S1 is at the best solution. Understand? S1 is at the best solution. S2 will be the second best position. Similarly, S10 is the S10 sparrow is at this place where there is a worst solution. Means known worst solution is at where sparrow 10th is available, and the known best solution is where sparrow 1 is available. So all these 10 sparrows should go to the next solution. That next solution is the best compared to the previous or not, that will be explained in the next step. Now the process, before moving into the second step, I want to explain what kind of movements are available for these 10 sparrows. Each one of the 10 sparrow is at one solution. So there are 10 sparrows. We have 10 solution in hand right now. Out of these 10 known solution, S1 is at the best solution place and S10 is at the worst. But don't think that S10 is just the complete worst. Maybe unknown worst will be more worst than this. Similarly, best S1 is at the best place. That doesn't mean that S1 is at the place where best solution is there. It is the known best solution, but there may be unknown position where there may be still better best position. So that's why now our objective is to find the best of known as well as unknown. Right now known is only 10. Out of 10, best is the S1. Correct. So this is the, so now these sparrows should move to the unknown, move to the other positions in some algorithm based, so that how sparrow will go to the new position to find the food, that is studied and understood, and same thing is going to be implemented here. That what I am. So here what happened, sparrows are divided into two parts. For the first part you can say this these are the best place, no, S1 and S2. I call them I call them as the producers. You see, I call them as a producers. So I call these are the producers. I can say these are the producers. So these are the producers. These are producers. So what these producers S1 S2 are the means they are the best position. They can search the new position independently. They are not following anything. But remaining these, I call them as the remaining thing. I call them as the sorry. I could not place. See, remaining things. Yeah, these things. I call them as the I call them as the scroungers. Scroungers. These are the scroungers. Just sponges. So this how producers moves to the next location. See, S1 is at the best known position. Now it may go to the another position where that is still better or maybe worse. We don't know. So, but it should move to the new position to find the still better one. Its intention is to find the better one. Let's see how it moves. S1 already at the best position, so it will try to look at the left or right, left or right, correct. So this is what option is. S1 and S2 are looking in the left or right for the food, because they are already at the place where food is available, but still they will eat something and they'll look left and right again. There may be some better food is there, so that is the one moment available for S1 and S2. So, but when it comes to squanches, they of course there is S3 is at the place where solution is there, but that solution is not best. So, and they are very near to S4, so they can easily S3, S4, and S5. They can try to follow the producers. Squanches will have one moment called following producers, following or towards best, I can say. So this is the one kind of movement. Means S3 will try to move towards S1. S4 is also try to move toward yes. But all sponges will not try to. For example, 58. Sorry, S8, eighth sparrow. It is very from maybe it can fly to this place. No, what I am telling, this can fly to this S8 can fly to this place. No, it can have it may see S8 can fly to this place and it can have some better food random position, because going to the place where S1 is there is very far for it. Maybe some random position may get. That's why this sponges will have another option like moving towards random random place, moving towards random place, correct. Moving towards random place. So there are two. See, these are moving towards random place and some are moving towards the best place. So two movements are available. So producers moves just left or right to find the better fruit, and sponges some 50% of the sponges move towards the producers where they can identify, and 50% of the sponges go out of the box because they are very far. So the movement. Now come in this moment. See, but producer is having another. If there is an external threat, see, producer is having sufficient food here and it is just searching for the food just nearby, left or right. If it notice some threat which is coming from outside, then again it has to fly out. It has to fly out. When? If there is a threat. So if there is a threat. See, you can notice that when there is a threat, they will try to go out of the box. If there is no threat, they will search nearby the place. When it comes to scroungers, they don't want to look at threat. Finding the threat is the responsibility of the producers. Scroungers are just like small childrens. The childrens will follow the producer or they will move independently. They are not thinking about the threat. So these are the two moments scroungers have this. But see, when you look at the diagram what it is shown on the screen, see, the box is very clear, maximum and minimum limit is set in the first iteration. So that most of the people are trying outside. See, only these three, and 50% are trying to stay within the boundary of max and minimum, because 6 to 10 are trying going out of the box, and only 5 is in this 5 also. If there is a threat, they will producers will try again outside. So people of going outside is very far. People moving out of the box is getting more, so that we may end up with losing the present best position. So we don't want to lose the present best position until unless we find the new best position. So that's the reason there is something we call it as scooters. Means, what is scooter? So scooter is again a group of sparrow. Scooters means it is again a group of the, see, this is what I can say. Scooters means again out of these 10, some 20% means some 2 3 plungers are selected to fit within the boundary. Means best known, best and forest. Known, best and, so known best and worst scooters. So means what happens, out of this 10, out of this 20% of the, means out of 10, 2 are selected as scooters randomly. It is not like that we have to select sixth sparrow or eighth sparrow or sparrow 4, like that. Randomly 2 are selected. Those 2 should be made to fit within this only. So that is taken 5 by the scooter, so that we should not lose the present best positions which can be searched locally, local search and all. So this, so when this totally how many movements comes, left to right movement of the producer. If threat is there out of the box, so there are two equations. Again scroller following the towards the best is one equation, moving towards random place is another equation. So again two equations for scavengers, two equations producers, and scooter will also, it should be between the boundary, no? If scooter is gone out of the boundary, it should be bring back inside the boundary. Correct. No, it's 7 2 high and low. If somebody goes out of the minimum, it should be come bring back. If somebody goes out of the best, that will also bring back. So to this we will have with the two equation. Those equations are explained here. You see, producer, if there is a threat, it goes to the random location. That's equation number 1. If there is no threat, it looks in left or right. So two equations for producer. And then scavengers is also two equation. One equation is towards move 50% of the scavengers move towards the best location, means best location, and another 50% will move out of the box. But it is very clear who are trying out of the box is decided by this. Those who are away, scavengers which are away from the producers will try to move randomly, but scavengers which are near to the producer, they will try to follow the producer. So this is the two equations for scavengers. This is the two equations for scavengers. Again after this fifth step, you can see this is for the scooters. Scooters means monitoring. So everybody goes out of the box, then we are going to lose the present knowledge. So to make that fit within the available present knowledge, at least two out of 10, two sparrows should be fit within the available knowledge, so that minimum two, maybe they will become more. When two scooters as well as produce are already inside, and some scooters are already inside, sponges are already inside the box, so like this. So this kind of equations we need to develop to implement while searching. This is the technique used by Sparrow to search the best food. So same thing we will apply to the solution of ocean, where we will come find the best solution. There are thousands of solutions. Out of thousands of solutions, we are going to find one best by applying this logic. Here you will come to know that there are six equations: two for producers, two for scavengers, and selected scooters will go through the best and worst equations. So like that iteration, they will move from one position to another, and we are tracking the best and worst in each cycle, and we will print the answer. Thank you very much for hearing this. We are from BBAK Technologies. I will you can see in our what we will say comment section. If you have any doubts, and if you want to implement any projects or something, please contact us, we will help you out. Thank you very much for looking at this video. Thank you very much.